ठीक आहे, आपण कार्यक्रमास सुरुवात करूया. गणित विषयाची भूमिका सॉफ्टवेअर मध्ये खूप महत्वाची आहे. मशीन लर्निंग पासून ते डेटा सायन्स मध्ये गणित हा महत्वाचा घटक आहे. याच अनुषंगाने महाविद्यालयाच्या प्लेसमेंट सेल, IQAC व गणित विभाग यांनी सॉफ्टवेअर इंडस्ट्रीमध्ये गणित विषयाची भूमिका याचे आयोजन, या छोट्याशा वेबिनारचं आयोजन केलेलं आहे. या कार्यक्रमाच्या प्रास्ताविकासाठी मी प्रतीक्षा आयरे यांना आमंत्रित करतो. प्रतीक्षा.
नमस्कार, मी प्रतीक्षा आहिरे तुम्हा सर्वांचे स्वागत करते. राष्ट्र सहकारी शिक्षण प्रसारक मंडळ लिमिटेड चाळीसगाव संचलित नानासाहेब यशवंतराव नारायणराव चव्हाण कॉलेज गणित विभाग प्लेसमेंट सेल आणि IQACच्या संयुक्त विद्यमानाने हा कार्यक्रम साजरा करण्यात येत आहे. तसेच नॅशनल लेवल 1 डे वेबिनार ऑन द रोल ऑफ मॅथमॅटिक्स इन इंडस्ट्री या कार्यक्रमाचे प्रमुख पाहुणे आणि मार्गदर्शक म्हणून आपल्याला लाभलेले मॅथमॅटिक्स एक्सपर्ट अँड सॉफ्टवेअर डेव्हलपर मिस्टर सचिन बिडवाई सर यांचेही मी मनापासून स्वागत करते. आणि आजच्या कार्यक्रमाचे अध्यक्षस्थान आपल्या कॉलेजचे प्राचार्य डॉक्टर S.R. जाधव सर यांचेही मी मनापासून स्वागत करते. तसेच उपस्थित सर्व प्राध्यापक वृंद आणि विद्यार्थी आणि विद्यार्थिनी मैत्रिणींनो यांचेही मी मनापासून स्वागत करते. आजच्या कार्यक्रमाचे मार्गदर्शक सचिन बिडवाई सर यांना मी विनंती करते की त्यांनी आम्हाला इंडस्ट्रीमध्ये मॅथमॅटिक्सचा काय रोल आहे याबद्दल त्यांनी मार्गदर्शन करावे.
Thank you, Pratiksha. Patil sir, can I share my screen?
Yes, yes.
Can you stop your screen presentation? Is I am audible?
Yes, yes, sir. Yes.
Yes, sir.
Is my screen is visible to all?
हाँ sir.
Hello.
Yes, sir.
Yes, sir.
Okay. Good morning, students. So today we are discussing the role of mathematics in industry. So very interesting topic. First we start with the Sanskrit sloka. Have you heard about this? यथा शिका मयूराणाम नागानां मनोय यथा तद वेदांग शास्त्राणाम गणितम मूर्धम वर्तते. जैसे मोरों में शिका और नागों में मणि का स्थान सबसे ऊपर है, वैसे ही सभी वेदांगों और शास्त्रों में गणित का स्थान सबसे ऊपर है. All this mentioned in our slokas. So start with our mathematics in industry. Can everyone switch off your mic? Lot of disturbances are there. Okay. So from 2010, first I give you brief background and then directly I jump with the application of mathematics in industry. So in 2010, India started Digital India concept. In that every document we can store in digital format. So that data, digital data is huge. Before 2014, all analysis part we did in the Excel sheet. But after 2014, big data is there because we collected every hard copy converted into soft copy. That means in PDF format, in Excel sheet. So that data becomes huge. So to handle that data, we need a programming. Then it is a combination of programming and statistician and mathematician role. So generally 3 sets are there. We observe here 3 sets, 3 circles are there. First circle is programming skill, second is statistics and mathematics, and third is business. So you aware about that role. If you have mathematics and statistics strong knowledge and you learn any programming language such as Python, then you can do machine learning. If you have programming skill and business knowledge, then you can become a software developer. If you have mathematics and business knowledge, then we can become a business analyst. And if you have these three skills, mathematics, programming skill, and business, then you can become a data scientist. So if you have a mathematics and a statistic background, then you have a lot of scope in data science field, in AI field. These two fields are growing now. So how we can develop a model? I give you naming in that domain. Suppose we can correlate a relation between dependent variable and independent variable. So y is equal to mx plus c, or I write there equation y is equal to m1 x1 plus m2 x2. If we can write such a scenario between dependent and independent variable, then we can say that in computer language, we can say that it is a supervised learning. And if we cannot get any relation between dependent and independent variable, then we can say that it is unsupervised learning. Here are some algorithms are there to solve supervised learning problems. That is, if it contains time related problem statement, then we use time series algorithm, regression line, it is continuous numerical data is there, and categorical data is there, then we use classification algorithm. If it is all supervised learning, then we use clustering, then association, all these things we use. So what is meant by artificial intelligence? Our concern with the building of a computer system that can mimic the human behavior and perform tasks with human intelligence. So machine now mimic our human behavior. This is an artificial intelligence. Now in machine learning, generally mathematics people role more. So process of programming computer to learn from historical data to make prediction on a new data. If you have data, we apply machine learning algorithm from previous data and we can predict future. This is a machine learning algorithm. Next is neural networking. As we know that our brain takes decisions. So how machine can take its own decision, that power we give by using neural networks. Then computer vision. You know that the camera is eyes of the robots. So we can say that this under the computer vision. Computer vision need computer graphics, physics, mathematics, sensor, image processing, and signal processing. That knowledge we require. Now we move toward the application part. Okay. Now here we can apply mathematics exactly, because my today's topic is the role of mathematics in industry. My interest is to show you how mathematics is applied. I choose some simple examples to show you how simple mathematical concept used in the industry, and we are aware about that simple concept, but how to apply we don't know. So let's see. Detecting a line, we can lines in image with hub line transform. So here we apply this concept. First I tell you mathematical concept, then we see the application of this. Suppose we have XY plane, and that line is break at point A and B, that line segment. So we get, suppose A point is 1, 2, A point is 2, 3. This is our image space. We have called it an image space. Now we have line equation y is equal to mx plus c, where m is slope and c is a y-intercept. Now I convert this equation. We are in xy plane now, because y is equal to mx plus c, it is xy plane, line in xy plane. Now I convert into MC plane. That means I write this equation in c is equal to minus mx plus y. I rearrange this equation only. Then I put that point A12 in that c is equal to minus mx plus y. So I draw that line in MC plane now. I put that point A12 in that equation, C is equal to minus M plus 2. Another point B also I put in that equation. Then we get, we know that how to draw the line. Okay. So I draw these two lines. We observe that if we have a single point in XY plane that maps to a line in MC plane. Let's see. That point is maps to this line, and this point maps to this line. How? Because in a previous slide we observe that when I put A12 point, then we get line in MC plane. C is equal to minus M plus 2. It is a line equation. So here we observe that XY A12 is a point in XY plane that maps to a line. So in MC plane. So we observe that mapping, if these 2 points intersect at one point, this two lines intersect at one point, then we can say that these 2 points are collinear. Okay. If there are, this is transformation. Now graphically I show you this 2 lines intersect. Just I use the graphing calculator to show you. So it is image space XY plane, and then it is a Hub transform concept. That means you observe in second figure, these blue dots in XY plane, these blue dots are collinear. When I map that those points in XY MC plane, every point is transformed to a line. If every point is transformed to line, we observe that if points are collinear, then they are intersect only one point, that means MC point. Then and only we can say that these points are collinear. Now we observe that a green dot is there. Green dot is not collinear with this blue point. So we observe that MC plane, that line is different, not passing through MC point. If points are collinear, then in MC plane, all lines are intersect only single point. This is collinearity concept. Okay. This is new concept. We learn 11th, 12th or different way. But for application purpose, they think in this way. I think this concept is new to all, I think. Okay. Now where we can apply this? So this is application. We can see these white strips on the road. Okay. And one left hand side or right hand side, we have continuous strip, white strip, and middle we have dotted. That means this line segment is break. We observe that this line segment are break. Now this application is used in auto car driving. So machine have to take the decision. So we consider this point is A and this point is B. So we can draw the hub lines. We can connect with the A and B with a line because they are collinear. We observe this. So we can draw the continuous line, and we can by using computer vision system, we can draw continuous lines are there. Okay, this is the line detection in OpenCV using hub transform. That mathematics concept used in self. That means we can say that automatic car driving. So machine now take the decision. We have to go through within that lane. This is our boundary. We have to go along that lane. Okay. That mathematical concept used here. Next is, suppose we can convert that line equation in polar form. Suppose. So it is image space dotted lines are collinear, dots are in a collinear. When we convert into hub line transform rho and theta, we can say that every curve is passing through single point. That means here also we can say that these points are collinear. Okay. where we use polar coordinates now. Then we have to detect any circular image, circular region. So here, circle, we have 4 points. Every point maps to a circle. In previous example, every dot is transformed to a line because we use the transform to MC plane using coordinates, Cartesian coordinate. That means now here every point is transformed to a circle in MC plane. So you observe that every circle is mapping to a single point. So every circle is passing through a single point. Then we can say that this point lies on a same circle. Okay. So we have this image. Then first we detect the edges. Then in third image we observe that circles are there. Okay, and intersecting point is that white nucleus, and we can detect the circle of this. Okay, so we can detect the circular shape by using Fock transform. Next application is histogram equalizer. So if we have an image and that image is, we can say that uh, dark image, and we have to bright that image. So we have to use some histogram equalizer methods. So you observe that this is first image is darkened, and we can equalize that image by using histogram equalizer, and we can see the result, it is brightened. Now how we can do this? So here is the concept. Now we have, I take one example on this. Perform histogram equalizer at image is there. Generally, a pixel size, we can have a screen or any image. Smallest unit is a pixel. So I take a simple example, 8 by 8 image for your understanding. Actually, screen have lot many pixels, so we have to consider every pixel. Okay. So for our gray level start from 0 to 256. Okay. So I took only 0 to 7. So in that image, 0 appears 9 times. Second column is the frequency. 1 appears at 8 times, 2 appears 11 times in this way. Then we can draw the histogram of this. Then gray level, PDF probability distribution function, CDF cumulative distribution function. This concept you I think learned at second year BSc statistics. So first I mentioned gray level, number of pixels. Then I probability distribution function. It is n divided by n. Then CDF means we have to take the values, add a second value, then again third value in this way. And then we have 7 observations, so multiply by 7, and then we can say that multiply by 7, then we get that value is converted to new value. So we observe here input image and output image. So that gray level is adjusted properly, so we can say that our image is brightened in that case. Okay, so this statistical concept is used here to we can say that normalize, brighten the image. Okay, so next application is, have you heard about the convolution theorem? In convolution theorem, we know that f of x star g of x is equal to integration 0 to t f of t g of t minus u dt. This is our convolution theorem. Now, how that convolution theorem is applicable in computer science field? So we know that this is image, and I draw a grid. Smallest square is a pixel, and we know that it is a color image. So basic color is red, green, and blue. So every color is made up of this red, green, and blue color combination. So now we observe that blue square is moving on a green square, we get the result in yellow square. Now it is a convolution. Now convolution, how we can apply? The blue square in first image that is moving, it is called as kernel, or we can say that it is a filter. And this is green square is nothing but our image, our screen. And one circle, one square is a pixel. For our understanding purpose, I took a smallest value, okay, 5 by 5 image. So when that maps on first part, we have to take in here matrix multiplication. How we do? We have to do corresponding image wise multiplication and add all these. We get the final result. For example, here we observe that this is a kernel. That kernel I put, that blue circle is nothing but the kernel value, and I multiply with the corresponding, we get the new result in a green. And for we can say that we add zero padding because we have to fit that square properly. So there are some padding techniques are different. Okay. So by using this, we can process any image. We can brighten and all these. This is matrix application in computer science. Okay. This is, so I show you. There is now I take a letter 0 and I apply this transformation. Now when I step by step moving that matrix, that filter be applying -1, -1, -1, and we get this calculation here. Okay, so when I multiply, we can observe here step by step progress is observed here. So I play this, you can see this. When that kernel is moving on this image, then we get the result. That number is 0 transformed to right side image. So in this way, that matrix, that kernel is applied on that image. So final result we get that we have to shrink or enlarge that image, or we have to change the color. All these operations we can do by using this matrix multiplication. And this is known as a convolution method. Okay. So which type of function we can apply here? Let's see. Method is behind that. So first order derivative for one dimensional function f of x is def by def by x. It is f of x plus 1 minus f of x. Second order derivative for one dimensional f of function f of x is this. Now how we can choose? Now I am showing a mathematical way how we can choose a kernel. There are different types of kernel. That different types of kernel gives the different results. So this is our Laplace equation. Del square f by is equal to def square f by def x square plus def square f by def y square. So I differentiate 2 times partially with respect to x. Then we get this equation. I just showing you. And then I substitute these values in del square f. We get this equation. Now how we can get the kernel, Laplacian kernel? So this equation we got, and I have to create a kernel, Laplacian mask or kernel. How we create this? Right middle, we have to create this 3 by 3 matrix. This is f of xy. Previous is f of x minus 1 y, and next is f of x plus 1 y. We have to write these coefficients only from above del square f. So f of x plus 1 y coefficient is 1, f of x minus y coefficient is 1. We know that f of xy coefficient is -4. So we get this matrix, and that matrix is called as Laplacian matrix. Okay, and we have to note this when we add all these elements, always we get the addition is 0. This is a property of Laplacian mass. When we apply this matrix, we get the result according to this. Then Gaussian matrix is there. This is Gaussian formula, and that kernel is this 1 1 1 2 1 2 4 2 1 2 1 into 1 by 16. When we use this to blur edges and reduce the contrast. We have to blur the edges, and if there is a lot of contrast, we can reduce by using this kernel. So we saw these images online right now. So you can observe this, that middle matrix is a kernel, and this is the left side image is a image. When that kernel is applied on this image, we get the output image. So in second image, we observe that we took a letter and we apply on this, we get the output image. Where we use, we know that OCR techniques. When we have a lot of application in mobile, when we scan any image, text image, that detect that is number or letter or this. So now we can convert image text to actual text. So here 2 is input. First is their convolution. How we can apply convolution here. So input image is 2, and we have to identify this is 2. So we observe this small box is there. That means that kernel is applied and maps to this point. So this process we repeated. This is kernel valid padding, then max padding, valid processing. Same process we can apply several times, and then we get the desired output. So this process is known as convolution process. We apply to detect any number or any features from the images. Anyone have question related to this?
कोणाला काही प्रश्न आहेत का?
Sir, I have one question.
Yes.
Derivative and integration, how to apply in practically? म्हणजे डेरिव्हेटिव्ह आणि इंटिग्रेशनचा आपल्या जीवनामध्ये काय उपयोग होतो?
Okay, I show you that application. I skipped that. Actually, time is not there. I show you derivative application. In short, yes. In neural networking, we observe that the partial derivative is used here. Okay. First, you know how I show you just it is a partial derivative we take daba jw by daba w2. I just use here chain rule. Okay, it is a back propagation method. There we use this. Now I tell you, scientists in deep learning, we have to create these such type of functions, and 1 minute, I'm showing. This is our neuron. Okay, nucleus and dendrites. Same as like our neuron, we create a function. This is input. We add some weight, and this is linear function and activation function. Then we get output. Okay, this is called as perceptron. How machine can take decision? We think on our brain how we can take the decision. Same way we created a mathematical function, and according to that, the machine now take own decisions. Okay, so this is logic behind that. So now input values are there: 1, x1, x2, xn, then w1, w2, wn, and then we take the sum. Then we take non-linear function apply on this, and then we get desired output. In this way, we get the function y is equal to g w naught summation wi. In this way, we get the such a type of function we get. And in Bragg proportion method, we need that partial derivative. Okay, to take the to check our decision is correct or not. Okay, so there are non-linear functions are there. Sigma, linear, piecewise, logistic, all these functions are you I think you heard about this. Just we apply this non-linear function to activate that function. Okay, logic is very simple. We have to apply properly. I think you understood that application.
Yes, thank you.
Okay.
सर धन्यवाद सर. अतिशय समर्पकपणे आपण गणिताचे ऍप्लिकेशन आमच्या विद्यार्थ्यांना सांगितले आहेत. आणि सध्याच्या युगात सॉफ्टवेअर फील्डमध्ये गणिताची भूमिका खूप महत्वाची आहे. जे सॉफ्टवेअरमध्ये जे छोटे छोटे कामं आता माणसं करत होते ते आता AI टूल करून घेते. जर आपल्याला सॉफ्टवेअरच्या स्पर्धेत टिकायचं असेल तर गणिताचं ज्ञान खूप अत्यावश्यक आहे. त्या पद्धतीने तुम्ही आमच्या विद्यार्थ्यांना मार्गदर्शन केले. आजचे कार्यक्रमाचे जे अध्यक्ष आहेत आमच्या महाविद्यालयाचे प्राचार्य डॉक्टर S.R. जाधव सर यांना मी अध्यक्षीय मनोगतसाठी आमंत्रित करतो. सर.
हॅलो.
हा सर, येतोय आवाज सर?
येतोय आवाज, येतोय ना?
हो हो.
आजच्या आपल्या या ऑनलाईन वेबिनारचे व्याख्याते आदरणीय सर त्यांनी आयोजित केले ते प्राध्यापक संदीप पाटील सर, उपप्राचार्य, सर्व प्राध्यापक बंधू भगिनी, विद्यार्थी बंधू आणि भगिनींना, मॅथमॅटिकल जे काही ऍप्लिकेशन्स आहेत या ऍप्लिकेशन्सचा जो काही रिअल वर्ल्ड मध्ये जो काही उपयोग आपल्याला होतोय तो अतिशय चांगल्या प्रकारे सरांनी आपल्याला सांगितले. त्याच्यानंतर आर्टिफिशियल इंटेलिजन्सच्या संदर्भामध्ये किंवा मशीन लर्निंग असेल, न्यूरल नेटवर्क, कम्प्युटर व्हिजन, मॅथमॅटिकल ऍप्लिकेशन्स, लिनियर कोलिनियर पॉइंट्स आणि हाऊ ट्रान्सफॉर्म कॉन्सेप्ट हा जो ह्या कॉन्सेप्ट त्यांनी अतिशय चांगल्या प्रकारे सांगितला. रोडच्या संदर्भामध्ये त्याचे जे काही ऍप्लिकेशन आहे म्हणजे अशा जे काही मॅथमॅटिकल कॉन्सेप्ट असतील, हिस्टाग्राम, इक्वलायझर, याच्या संदर्भामध्ये सरांनी PDF CDF खूप चांगली माहिती आपल्याला दिली. खरं म्हणजे बरेच कन्सेप्ट, माझं पण मॅथमॅटिक्स होतं, परंतु आता हे जे काही कन्सेप्ट आहेत हे आता अतिशय नवीन कन्सेप्ट याच्यामध्ये आलेले आहेत आणि हे जे काही ऍप्लिकेशन्स आहेत अतिशय चांगल्या प्रकारचे मॅथमॅटिकल ऍप्लिकेशन्स आपल्या रिअल वर्ल्ड मध्ये आहेत. म्हणून विद्यार्थ्यांनी हे जे काही ऍप्लिकेशन्स आहेत हे अभ्यासले पाहिजेत. सरांनी खूप चांगलं मार्गदर्शन केलं. परत सरांनी अजून आमच्या विद्यार्थ्यांना नंतर या संदर्भात जास्त वेळ देऊन मार्गदर्शन करावं अशी मी विनंती करतो. आणि तुम्ही हे जे काही मार्गदर्शन केलं त्याबद्दल महाविद्यालयाच्या वतीनं मी आभार मानतो.
थँक्यू सर.
प्रतीक्षा, आभार प्रदर्शन.
हो सर. आजच्या या कार्यक्रमाची सांगता करण्याची जबाबदारी माझ्याकडे आली आहे. सर्वप्रथम राष्ट्रीय सहकारी शिक्षण प्रसारक मंडळ लिमिटेड चाळीसगाव संचलित नानासाहेब यांना चव्हाण महाविद्यालय यांच्या IQAC ट्रेनिंग आणि प्लेसमेंट सेल अँड कमिटी आणि गणित विभाग यांचेही मी आभार व्यक्त करते, कारण त्यांनी आपल्याला या कार्यक्रमासाठी परवानगी दिली आणि अतिशय चांगल्या रीतीने कार्यक्रम साजरा करण्यासाठी परवानगी दिली. आणि त्यांना आजच्या कार्यक्रमाचे मार्गदर्शक मिस्टर सचिन बिडवाई सर यांचेही मी मनापासून आभार मानते. त्यांनी आपल्याला मॅथमॅटिक्स रिअल लाईफ मध्ये कसे यूज होऊ शकते आणि कसं प्रॅक्टिकली ते आपण अप्लाय करू शकतो त्याबद्दल त्यांनी माहिती दिली. त्यांचेही मी आभार व्यक्त करते. तसेच आजच्या कार्यक्रमाचे अध्यक्ष प्राचार्य डॉक्टर S.R. जाधव सरांनी आपल्या आजच्या या कार्यक्रमाचे अध्यक्षस्थान भूषवले व आपल्याला मार्गदर्शन केले त्याबद्दल त्यांचे मी मनापासून आभार व्यक्त करते. त्याचप्रमाणे IQAC चे कोऑर्डिनेटर डॉक्टर J.D. देशमुख सर आणि उपप्राचार्य डॉक्टर UR मगर मॅडम व गणित विभाग प्रमुख आदरणीय S.G. सोनवणे सर यांनी आपल्याला वेळोवेळी मार्गदर्शन केले त्यांचेही मी मनापासून आभार व्यक्त करते. तसेच आजच्या कार्यक्रमाचे संयोजक प्राध्यापक S.N. पाटील सर व कमिटी मेंबर ज्यांच्यामुळे हा कार्यक्रम शक्य झाला त्यांचेही मी मनापासून आभार व्यक्त करते. त्याचप्रमाणे महाविद्यालयाचे सर्व उपस्थित प्राध्यापक शिक्षकेतर कर्मचारी व सर्व विद्यार्थ्यांचेही मी आभार व्यक्त करते व अध्यक्षांच्या परवानगीने हा कार्यक्रम संपला असे जाहीर करण्यापूर्वी सर्वांनी फीडबॅक फॉर्म भरावा त्याची लिंक चॅट बॉक्स मध्ये आहे. धन्यवाद.
सर्वांनी आपला कॅमेरा ऑन करा. मला एक स्क्रीनशॉट घ्यायचा आहे, फोटो घ्यायचा आहे. कॅमेरा ऑन करा सर्वांनी.
थँक्यू प्रतीक्षा. थँक्यू संदीप पाटील सर.
सर्व विद्यार्थ्यांनी कॅमेरा ऑन करावा. धन्यवाद. कार्यक्रम संपला आहे असं मी अध्यक्षांच्या वतीने जाहीर करतो. धन्यवाद.
थँक्यू.
थँक्यू सर.
थँक्यू.